I'm gonna explain a little bit about the prosthetics that we are designing. We are team number one, and the name of our company is placed on the cover of the robotic hand. As you can see, the name is Electro-8. So I would like to talk about a little bit the materials, and in this case, we are going to print it with PETG, which is a material that is better for use for the printers because of its sensitive of heat, and instead of PLA, which is the most common material they use it to print 3D designs and all that kind of stuff, we are going to use PETG. Okay, now I'm going to talk about the part of the robotic hand. The part that is highlighted in blue is which is the palm of the hand, and inside of it will contain the servo motors. In this case, we have 5 servo motors inside. The rest of the space that we have of the hand here is where the battery as well as the microcontroller and the driver for the servo motor will be placed. You can see that this part can take off from this one, and that is why if something breaks, we can replace it. For example, if this part breaks, we can replace it, or if this one breaks or something from this, we can replace it. And the connection between this part will be by wires. It's just a wire communication that will communicate the sensors that will be placed. Let me show you around here, which is the part where the limb was cut, you know. And to support the prosthetic to the arm, to the limb that was imputed, sorry, we have this like it's a hood, like a hood, and we close it, and we surround it with a strap, which will contain the prosthetic attached to the arm, to the limb that was cut. And if the user wants to take off, just open it, and it will open and take off. Uh, about the fingers, okay. One of the difficult parts is that a foot, sorry, a feet, and I think those only toes are the most complex limbs from a body to replace and design. I make a draw first, and then I design it in 3D. As you can see, here are the connections for the fingers. These ones are the ones which connect the fingers to the palm, and this finger, which is the finger most important for humans, was one of the most difficult than the rest of them. Why? Because this one moves inside of the palm and then flex around here. That's why it was a little bit difficult to design it. And the rest of them just flex in one direction. Here we have 2 directions, to the left, to the right, and from up goes up and goes down. And this one don't. This one just flex from up and down. In this case of the design, you can see if I try to put it down, it goes down. And this is for all the fingers. Goes down, and stays over there. It looks like I is saying this and up. Okay, for the way that we are going to move the fingers, the servos that are inside will be placed here and connected to the fingers by a cable, a wire, that will be passing through the fingers by these holes. The top hole is to support the fingers with a like a metal stick that flex. And why we are using this? Because the finger will stay in a vertical position, and when we activate the servo, it will flex. And the way that we are going to do that is by attaching a cable or a nylon wire from the second hole, which is at the bottom. And you can see it here also. Every piece, this is the piece finger 3, and every piece has a hole, has 2 holes. One for like a spring, for an action like a spring, and the other one for like a strap to produce the movement of flexing the finger. And the strap will be rolled on like a roller here by the servo motor that will be placed here. This is basically the description of the design and as well as the function. You can see that the fingers can flex from stay all full extended to compress it and to be able to hold some objects. Let's put it normal. And you can see the number of parts that we have are 1, 2, 3, 4, 5, 6, 7, and 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 17, 18, and 19, and 20 for the color. I don't count the servo motors because it's not 3D design, it's just a model. And I just put them here to illustrate how they will be placed. On the cover you can see here that it's transparent, but actually no, it will be of the same material as this one, and this one too. But it's just for illustrate how the components will be placed inside. Also, I wanted to talk about this mechanism that was quite complex to design. The way it is open is by introducing a shaft here in the middle of the hole, which also passes through the piece that is at the top and at the bottom, and crosses all the way until here, and it will produce a movement that it will allow to open and close this, attach and unattach the prosthesis to the limb that was cut.